I want to take a few minutes to offer my thanks and heartfelt appreciation to many people for all the support the Angel Fund has provided us. And I then want to provide a short update on where things are in ALS research, both at UMass and a bit more generally. First of all, I want to thank the Angel Fund organizers who have done so much to make this happen, including the remarkable Nigro family, Rich Kennedy, Ann Hadley and their team. They've just done a wonderful job at every stage here. I want to also give my thanks to the lab members who do the work so brilliantly in the laboratory. We're fortunate to have a wonderful group of young investigators with us now who really have pushed the frontier in terms of understanding this disease. I will tell you, when you have an exciting lab, it's fun just to get up and go to work, and they certainly make that possible. I want to thank, perhaps even more than that, most of you who are here as part of the broader ALS family. Those of you who have either known ALS personally or know people who've had ALS, it is your effort, your tireless support of the Angel Fund that has done so much to promote the research. And all of us in the lab are profoundly grateful to you. A bit of an update in terms of what's going on in the laboratory. Briefly, the concept we pursued in the lab is trying to figure out what can cause ALS. Then once we know the trigger, we try to sort out why it is that pulling the trigger ultimately causes motor neurons to die. We look at what we learn from that process to try to devise therapies, and then ultimately, of course, to go on to do trials of those therapies. So that's kind of the driving, as it were, flow chart or spectrum of a process here. And within UMass, we have now, if you can believe it, 10 laboratories that one way or another are working prominently on ALS. So at the discovery end, we've had, fortunately for 15 years, the wonderful work of John Landers, who has found several ALS genes and who additionally has organized a global consortium to pull together whole genomes, all the DNA sequence of thousands of ALS patients, to see what we can learn when we look at them in aggregate. In terms of the biology from the genetics, we're blessed to have Daryl Boscow, who's done a fantastic job figuring out why protein pathology can trigger this disease. She's looked at a protein called TDP43 and another one which is called ataxin-2, which is just as relevant to sporadic ALS as it is to familial ALS. We're also very fortunate to have had for 4 or 5 years now Dr. Nils Henninger with us, who has studied the incredibly interesting relationship between carrying a genetic defect on the one hand and having head trauma on the other that then provokes neurodegeneration. And he's made substantial progress in that using animal models. Been very, very exciting. Additionally, as you know, we have Dr. Fenbiao Gao, who studies the relationship between ALS and frontotemporal dementia. And this is just to name a few of the laboratories. Now, in terms of therapy development, we also have a remarkable team that engages in what you might call precision therapy. And this is a team that looks at what's the gene doing when it causes ALS? How can we modulate that gene? Can we turn it off? Should we be turning it up? Should we change the way it's spliced together? Or can we go into it and edit it and correct it once and for all? And I will say that's one of the reasons why it has been so exciting to be at UMass. So we have Jonathan Watts, in fact he's here tonight, who's been pivotal in helping us develop a treatment for the C9 gene in ALS, and who has recently very innovatively discovered a new type of gene modulator which really has 2 warheads, if you will. One therapy that treats 2 aspects of the disease at the same time. Just incredible. Also incredible is the work of Anastasia Kforova, who's developed an entirely new type of gene suppression, which is much more effective than what has come out so far. So I think in this sense we're very lucky. The latest thing in this field is gene editing. There's a lab headed by Eric Sontheimer, which is now deeply engaged in looking at gene editing in familial ALS. We're blessed to have Karen Majboom, who's working on that in our laboratory. And that's just a few of the labs. I won't go through all of them. But then the far end, of course, are trials. And there we're very lucky to have a wonderful trials group. A lot of great coordination from Kat Douthright, whom most of you know, and others such as Dr. Owegi. So I would say this is a very, very exciting time, not only for us in the lab, but also for the field in general. As you know, there are now 5 approved FDA-sanctioned drugs for ALS. They don't quite do enough, but they're there, they're approved. We, of course, want to increase that number greatly. It's interesting that there are now something like 6 or 7 drugs in trial on a platform basis. And as well, I can rattle off the top of my head 14 or 15 startup companies focusing exclusively on ALS. So in terms of the general context of ALS research, this is really a remarkable time. Thank you very much.